millions. So they sold in the millions back in those days. So it was worthwhile to think first how to program games for 6502-based processors. But the trouble comes from the fact that they all have dedicated hardware for video, sound, etc. So they all have different chipsets, and there was a registry maps of all those chipsets are different. How they work is different. So it's not immediately obvious how you can find a commonality for all of those platforms. So of course, if you were back in the day, you would have basically had to buy some user manuals and programming manuals, like mapping the Commodore, mapping the Atari, and then spend a lot of time trying to learn about the registry of each machine and how they work. And it's sometimes very obscure, and you can spend a lot of time trying to just learn one little thing and make it work. For example, this is here showing one of the registry for sprites on the Atari, which is very complex because each of the bit does something different with some interaction between player and playfield. There's something called the fifth player, which can also be missiles. Then you have to copy directly into memory from your sprite frames to special location on the memory here, which is dedicated to player missile graphics. It's completely different than the way it works on the Commodore 64, and of course, completely different from other systems which don't even have sprite support, like the Apple II. So seeing the difficulty to implement games sort of piecemeal for each platform, the idea came of trying to create a simple C API for the CC65 compiler, which supports quite a lot of different platforms. And so far, I've got an engine that's written about 60% in assembly and about 40% in C. And all the time, the assembly part is growing. Of course, the assembly code is much faster. And the C code contained in the engine is decreasing. But the important point is that the assembly functions are made accessible through this C code API. So it makes it very easy for someone who has no experience of assembly programming, but a little bit of C coding experience to get going and make a game for the Atari Lynx or the Commodore 64 or the Oric Atmos shown here. So also the SDK is not just a C API, it's also all the tools needed to create a game and package it directly onto a floppy that you can then distribute. I'm going to go in a little bit of detail of the various aspects of this SDK, which allows you to create entire games. First of all, looking at the bitmaps, you can do all of the heavy work in an application like GIMP, where basically, if you download the 8bit-Unity package, there is a portable version of GIMP that is set up to help you quickly get your assets formatted to the right palette and the right resolution. So you start from a common artwork and you quickly go into the different palletized versions that you want to use for each platform. You have the ability to draw characters on top of bitmaps, which is very handy for creating advanced interfaces where you have graphic and text on the same page, so to speak. And since version 0.3, the SDK even contains a widget system so that you can automatically manage menus, chat boxes, scroll box, etc. There's also support for scrollable char maps, and support has been centered on CharPad, which is a very good application, originally written for the Commodore 64. But the trick is the documentation shows how, having created your map in CharPad, you can then export the binary map, which is going to be used by all platforms. And then you can make a different palletized version of the character set, again using GIMP. And so here I'm showing the Quedex example of tile set. And this is what it looks like in game for the various platforms which are currently supported. So you've got the Apple in single resolution here, in double resolution here. Here you've got the Atari. Sorry, my screen is going a little bit strange. I don't know why. Here you've got the Commodore, the Lynx, and the Oric. Of course, the quality of what you're going to be seeing depends on the platform. For example, on the Apple, there's no actual support for character maps. So it's actually a full bitmap that is displayed and has to be refreshed as you scroll around the map. But you can see the Atari, the Lynx, the Commodore are quite fluid. So for sprites, instead of using a dedicated sprite editor for just one platform, an editor called P-Scale is used, which allows you to just go from one platform to another by slightly changing the resolution and available number of colors. And starting from one high resolution sprite, you can easily rescale it and adapt it to each platform. There's a unified sound effect system, so you can easily play an engine sound, blip sound, gun sound. That's going to be pretty consistent across all platforms. And there's compatibility with all the popular track formats. So on the Commodore, that would be the SID, on the Atari, the RMT, and so on. Importantly, also, there's networking support in this SDK. And there's a library called IP65 that is compatible with a number of interfaces that were created for different platforms. So the RRNet on Commodore, the Dragon Kart on Atari, and the Usenet on the Apple. So all of them share a common chip. And so there is this IP65 library that's been integrated with 8bit-Unity. And there's also another interface, which is the 8-bit hub, which I'm going to present in a little bit more detail in one instant, that is supported. And any of those interfaces through the simple C API can send and receive packets in UDP or TCP protocol. It can also download directly from URL. So you can download resources files or make queries and so on. So here I'm just showing an example of a Python server, which you might be easily implement at home or on a Linux box. For this 8-bit hub, so that's a product, a hardware I've been developing, especially to be compatible with the 8bit-Unity. And there is one COM interface, and you can get a cable for any of the platforms that is supported by 8bit-Unity. So where they connect depend on the target. On the Apple, that might be the serial port. On the Commodore, the user port. And that hub gives you quite a lot of functionality. It has a Wi-Fi chip inside. There's a micro SD slot, up to 3 joysticks, as well as a PS2 mouse connector. And there's already a number of applications that are using this 8-bit hub. One is called 8-bit Slick. It's an online game. And the other one is called 8-bit OS, which allows you to see the content of the micro SD card and also use the mouse to scroll around the screen. So finally, once you're done preparing all your assets, you've done your bitmaps, you've done your sprites, you've done your music tracks, and you have written your code, it can be very difficult to then know how to all put that into a floppy that you can then load onto your target platform. So there is a Python packager which does all the hard work for you, and that's going to produce a D64 file for a Commodore or an ATR file for an Atari. And then you can take this image and you can run it directly on your hardware if you have a SD card reader, and then you can use some kind of copy software to copy on the hardware from your image to an actual floppy disk if you want to distribute. All right, so there's a number of games and apps that are in development. Some have been finished already. So The most exciting at the moment is 8-bit Slicks. That's a multi-platform game compatible with Atari, Commodore, Lynx, etc. You can play it online up to 4 players, and it's got a competitive ranking system. Bit of feedback now. I'm working currently on another game called 8-bit Strike. Sorry, someone have got their microphone on. Could they stop it? Right, I think that's better. So another game under development is 8-bit Strike. So it's a 2D version of Counter-Strike, which is going to be available on the C64, Atari, and Lynx. And the rest are pretty much tech demo at the moment. A little tech demo inspired from Worms, another one from the game Goblins. Here there's an attempt at producing something like the Apple OS system, so little apps that you can download. And then there's a game here, a sort of asteroid game that is under development. So what is for the future? The next version of Unity will come in November. Currently, you can download version 0.4, which contains everything I've just shown. And the next version coming in November will have a new platform, that's the NES, as well as support for parallax scrolling. All right, and that's all for me. I think I'm just finished on time.
Yes, thanks, Anthony. But let us have maybe some questions. Maybe I will start. So you said we can download it. Where can we download it? Can you put maybe the link somewhere in the chat later on? Or
yeah, just go on www.8bitunity.com. So it's very simple to remember.
Yeah, indeed.
Yeah. Yeah, we can put it in the chat as well later on. But yeah, 8bit-unity.com.
Excellent, thank you for that. Is that free to download? Is it?
Yeah, free to download, and you know, the license allows you to sell games that you produce with it. There's no problem.
Perfect. Is it open source? Can people modify it or?
Yeah, all the source code is on GitHub, and so of course on GitHub you can fetch the latest version, but it's not guaranteed to work with everything. But if you're interested to see how the NES is going, you can see on GitHub the latest version.
Excellent. And then this 8-bit hub that you mentioned, that's something you built.
Yeah, it's something that's based on an Arduino originally, and that also is open source in the sense that if you go on GitHub on my page and look for the 8-bit hub, you will find all the Arduino sketches and all the wiring diagram to build one yourself. Of course, it's, you know, I've got a system set up here now to produce them, so it can be more convenient to buy one from me. And those are available for sale on the 8bit-Unity website as well. There's an 8-bit hub section.
Excellent. That's good to know. That's good to know. I see some questions are popping up. You can also feel free to unmute to ask your question. I see here from Wilfried, great system. Thanks for the presentation. Is there a chance to have support for the Sinclair Spectrum in the future? Sinclair.
Yeah, so going on the Spectrum, it's a Z80-based computer. So I've focused for now on 6502 because it's the same compiler. But it is planned to also support Z80. The Amstrad CPC and the Sinclair on the roadmap. But we're thinking maybe 2 years from now, something like that.
So you will spend your winter evenings on that.
Yeah, I've already spent many winter evenings in the past 3 years.
Good. I don't know if there are other questions. People in the room. I'm not looking, I must say, I'm not looking. I see that there are some people on Facebook as well, but I cannot monitor the 2 screens at the same time. If no more questions, I would say thanks a lot, Anthony. Maybe more questions come in the chat, so if you can stay a bit around and see, or just type in again the 8bit-Unity, the link there, and then I will give the word.